we will get going. So I was saying, I hope you all had a good weekend. I'm sure it was fun, filled with exciting travels to many exotic places, or at least through Netflix. For most of you, I got your homework number 2. There's a couple of you that I have not yet gotten homework number 2. You need to submit that to me as soon as you can, or at least let me know if you're not going to submit homework number 2, or if you're going to submit it late. My plan actually is to go over homework number 2 this afternoon. So I woke up early and I graded many of your homeworks. I'm going to try to finish them over lunch, send them back to you so you can take a look at them after class, and then we'll go over them this afternoon. And I kind of wanted to go over homework number 3 this afternoon, because you might find it useful for homework number 4 that is due on Wednesday. Okay, so we will finish up some material that we didn't get through this afternoon, and then we'll go over homework number 3, because I think there's probably some questions a few of you have on homework number 3. There's certainly some things I want to emphasize on homework number 3, that as I've looked through the homeworks this morning, we're making some consistent mistakes, not major mistakes, but consistent mistakes. And so I want to go over those carefully before you get too far into homework number 4, okay? So homework number 3, if you have not submitted it to me, let me know. It's going to be late, if you're still planning on sending it. And then we'll go over that this afternoon. Anybody take a look at homework number 4 or get started on homework number 4? Probably not. Probably busy with homework number 3. Well, you can certainly get started on that today, and that would be a good idea, because this one's due Wednesday morning. All right, so we have a very busy homework schedule here at the beginning of the week as we get ready for your second exam on Thursday. So make sure you spend some time looking over homework number 4, so that if you have any questions, you can ask. I've tried to cut homework 4 back a little bit, not quite as long. I mean, I guess that's probably will differ between individuals, but at least in my mind, I've tried to make homework for number 4 a little bit shorter, so you can get it done in good time. But that, as I said, that's going to be done on Wednesday. So nobody has any questions about homework number 4 as we're thinking about it? Well, we're talking about assignments. If you remember in this class, we have a writing assignment, right? There's a macro paper. And so this is really kind of a short current events paper, 3 to 5 pages, in which I ask you to kind of do some longer analysis about current events, but do that analysis through the lens of the macro models that we've been using in this class. So this is not due till next Monday, but we've gotten to the point in class where you're probably ready to begin working on this, or at least close. Certainly by the end of class tomorrow, I think we should have covered all the material that I think would be useful, or most of the material that I think would be useful for you in doing this paper. And so when I send you out the agenda for tomorrow, I'm also going to send you this assignment, okay? And so as I said, I'm sending it out a little bit early. It's not due for a week, but I know that a couple of you wanted to take a look at it early if you could, just because there's other things going on in your life. And also that just kind of gives us all a little bit more time to kind of sit and think about it. So I realize for most of you, you're probably not going to spend too much time thinking about the paper until after the exam on Thursday, which I understand. But anyway, I wanted to send that out early, just so you could take a look at it. So we'll talk more about the macro paper as we go along. All right, I won't have too much to say about it now, but you might at the very least just want to kind of look at the assignment, right? Glance through it, and if there's big questions, then we can talk about it as we go along. All right, good deal. Any other questions before we get jumped into this thing, get going? All right, well, if not, our unending trek towards figuring out our short run macro model continues. And today it continues in chapter 13, all right? And really today, we're going to add on a little bit to our short run macro model by talking about aggregate demand and aggregate supply. doing this does not mean adding on too much, just a little bit. But then the other big thing we want to talk about today is stabilization policy. How exactly should stabilization policy be run in our short run macro model? And then, of course, also some of the dangers, right? Some of the benefits of stabilization policy, some of the dangers of stabilization policy. So let's just begin here by reviewing the parts of the short run macro model that we already have. So the first part of our short run macro model was our IS curve. Right, we derived this last week. There's our IS curve. Remember, short run output is a function of the real interest rate. On Friday, we derived the Phillips curve. And if you remember, the Phillips curve tells us how inflation, or the change in inflation, relates to short run output. So we said the change in inflation is equal to some relationship here because related to short run output, and then O bar, which is the supply shock. And if you remember the intuition of the Phillips curve, which was a question on your homework number 3, is that this is because of capacity constraints, right? That's why the Phillips curve looks like it does. When short run output goes up, that puts upward pressure on inflation because of capacity constraints. And when short run output goes down, we have excess supply, and that puts downward pressure on inflation. And then the third part of this was the MP curve. And this is the part that we didn't really build out very much. We just assumed the Fed sets the real interest rate wherever it wants, and that's the MP curve. Right, so the MP curve is the Fed sets the interest rate wherever it wants. But what we want to talk about today is, can we say more about this? How does the Fed set real interest rates? What should its goals? What are the goals that central banks should try to achieve? So let's think about this. And to begin with, let's assume that the central bank sets a simple goal. Let's assume that the only thing the central bank cares about is inflation. This is too simple of an assumption, as we're going to talk about. But to keep things simple as possible, let's just assume that the central bank has an inflation target, right? They have to achieve a certain inflation rate, or they should be trying to achieve a certain inflation rate every year. So in other words, we could develop here a monetary policy rule. And what could this rule look like? Well, it might look something like this. Where pi bar here is your inflation target. So this is an inflation targeting rule. An inflation targeting rule. What this says is that the central bank, their primary goal is to try to hit a targeted inflation rate, right? So the inflation target could be 2%, for instance. And what the central bank then is trying to do is they're trying to get inflation at 2% every year. So if you think about what this equation says, what happens if inflation is above the target? What this means is that the Fed has to increase interest rates above the marginal product of capital. In other words, the Fed has to slow the economy. If inflation is too high, it's the Fed's job or the central bank's job to slow the economy. Vice versa, what happens if inflation's below the target? In this case, they want to try to speed up the economy. Inflation is too low. This likely means the short run output is too low. And so what should the Fed be doing? They should be cutting interest rates. So this rule that we developed here is actually, I think, pretty intuitive. It's pretty simple, right? It's pretty simple. And it's a little bit more detailed than what we just were assuming last week, assuming the Fed just sets the real interest rate wherever they want. Well, now we have a rule, right? The Fed is actually setting the real interest rate depending upon where actual inflation is relative to its targeted rate of inflation. So if actual inflation differs from the targeted rate of inflation, that means that the Fed has to change real interest rates relative to the marginal product of capital. So this becomes a third part of our short-run macro model. This monetary policy rule joins the IS curve and the Phillips curve as the three big equations in our short-run macro model. Now, so notice here that our MP curve on the left-hand side is just the real interest rate minus the marginal product of capital. What happens if we plug this into our IS curve? What do we get? We get this. This looks just like our IS curve, except now instead of interest rates, we have inflation. What could we call this? A curve that relates inflation to short run output. This is an aggregate demand curve. It's an aggregate demand curve. It relates demand to goods and services to the inflation rate. In other words, if we have a graph here with short run output on this side and inflation, notice this is not the change in inflation like in our Phillips curve, the level of inflation. What does this look like? Downward sloping. So what we've done here is by creating a monetary policy rule, we now can turn our IS curve into an aggregate demand curve that relates the level of inflation to short run output. Let's think about the intuition here. Why is aggregate demand downward sloping? All right, let's think about this. When we think about this, you have to use the model to think about this, right? This is going to be, just as an aside, as I was great looking over your homeworks number 3, I did see one consistent problem with many of your homeworks that I'm going to emphasize this afternoon when we go over your homeworks. You have to use the model when answering questions, right? So some of the questions that I asked you that were a little bit more open-ended, such as, that question about the fall in capital. Notice that a lot of you kind of just answered the model or answered the question like what you thought. You didn't actually use the model to answer the question, okay? So you just can't rely on your own intuition to answer these questions. You got to use the model. So in this model, why is aggregate demand downward sloping? Because what happens if inflation goes up? An increase in inflation causes what? We go back to our monetary policy rule, it causes real interest rates to go up. In other words, the central bank has to raise real interest rates. And when we do that, that reduces your IS curve and lowers short run output. Okay? So in other words, our aggregate demand curve is downward sloping because of this monetary policy rule. Higher inflation causes the central bank to reduce interest, or I'm sorry, higher inflation causes the central bank to increase real interest rates. That, I'm sorry, this is probably not the most accurate thing. I shouldn't say it shifts down the IS curve. Actually, probably a better way of saying this is it moves you along your IS curve by increasing your MP curve. Okay. Right. So if the real interest rate rises above the marginal product of capital, the MP curve goes up and that reduces short run output. That's probably a better way of saying that. So that's the intuition, right? So if I could just draw a graph here, think about what happens. Go back to our ISMP graph. Okay. What happens when inflation goes up is that now the central bank has to increase the MP curve, right? They have to raise real interest rates above the marginal product of capital, and that reduces short run output. That's the intuition behind why the aggregate demand curve is downward sloping. So, listen, if you ask a question like, why is aggregate demand downward sloping? A lot of us want to say, oh, well, it's downward sloping because when prices go up, it causes people to buy less goods. That's not the intuition, right? First off, that's faulty intuition because remember, this is inflation. This is the aggregate price level. If all prices go up, you don't buy less of some goods and more of some other goods because there are no other goods. All goods have gone up in price. So that's just bad intuition, but it's also not the intuition of this model, right? In this model, when inflation goes up, why does aggregate demand go down? Because the central bank's going to raise interest rates, right? That's the intuition, right? And so this is the practice that we have to get ourselves into as we think forward to exam number two, right? Using the model to answer questions, not just kind of using the intuition that you want to use to answer these questions. If I can go all the way back to our aggregate demand curve here, notice what determines the slope of the aggregate demand curve. The slope is determined by two things here. And I guess I didn't define what M is. I should have done that. okay, is based on two things. First, B bar. We've talked about B bar a lot, the elasticity of investment, right? How sensitive investment is to a change in the interest rate. But there's also something else here, M bar. What's M bar? You can think about M bar as how strict the monetary policy rule is. How strict. Let me rewrite the monetary policy rule here. Whoa. Well, we're having some sort of malfunction with my pad. Right, here's our monetary policy rule again. Think about M. As M gets higher, it means that the central bank responds to an increase in inflation with a bigger increase in the real interest rate. So, you know, M here, I think you could kind of think of as how tough is the central bank? How tough are they? Right? Are they going to respond to any increase in inflation aggressively by greatly increasing interest rates? Or are they going to be more careful, right? Are they going to be aggressive or are they going to be cautious? As M gets bigger, the central bank gets more aggressive, okay? And so in our aggregate demand curve, these are the two things that happen. What happens when M bar gets up? Or when M bar is higher and the central bank is more aggressive? What does that do to our aggregate demand curve? Let's say this is the aggregate demand curve with a low M bar. What's the aggregate demand curve going to look like as M bar goes up? Well, let's go back to our aggregate demand curve here. If M bar goes up, it means that any change in inflation is going to have a bigger change in short run output, right? A higher M means any change in inflation is going to have a bigger impact on short run output. In other words, this aggregate demand curve gets flatter. And if you think about the intuition here, that makes sense. Because what does a high M mean? A high M means the central bank is more aggressive fighting inflation. And if they're more aggressive fighting inflation, what are they going to have to accept? Bigger changes in short run output. Okay, so notice here for any change in inflation for this second curve, there's going to be a much bigger change in short run output. So the more that a central bank focuses on inflation, the more likely they are to have to accept bigger changes in short run output. Right? Does that make sense? So M is one of the things that impacts this aggregate demand curve. Likewise, B is the other thing. And B impacts the slope of the aggregate demand curve in the same way that it impacts the slope of the IS curve, right? If if investment is more elastic, that means you're going to get a bigger change in short run output every time that there's a change in the interest rate or a change in inflation. So here, you could think about the same answer here if you replaced M with B, right? Because a higher B means that investment's going to change more whenever inflation or the interest rate changes. Okay, so any questions about our aggregate demand curve? Now you might know where you might be able to guess where we're headed next. We have an aggregate demand curve. What about aggregate supply? Well, let's talk about that. Luckily, the aggregate supply curve is a lot easier because we've already developed it. It's the Phillips curve. It's an aggregate supply curve because it's talking about the supply side of the economy. So we express the Phillips curve like this. Or we can write it like this. So when we write the Phillips curve in this form, we're going to call it the aggregate supply curve. Okay? So when we use the change in inflation on the left-hand side, we'll call it a Phillips curve. When we use the level of inflation on the left-hand side, we'll call it an aggregate supply curve. But they're the same basic ideas. Why capacity constraints? As your question on homework number 3 asked you to think about, what determines the slope of the Phillips curve, and what determines the slope of the aggregate supply curve? V. So notice here, our aggregate supply curve says there's a positive relationship between inflation and short-run output. And slope is equal to V. And what determines V? The tightness of capacity constraints. If they're very tight, then what's going to be true? If that's what an aggregate supply curve looks like with low V, sorry, my V's look like U's today. All right, if that's what an aggregate supply curve looks like with a low V, this is what it's going to look like with a high V. Okay, so when you have a higher V, notice here that anytime you have short run output change, you're going to have a much bigger change in inflation because capacity constraints are a lot tighter. And so that's the intuition, right? A high V makes aggregate supply curve more steep.
Hey, Todd.
Yes.
I don't understand. Should there be an intersection with these two lines? If you're only changing the slope, then I don't see why these two intersect. Like there.
Well,
they're the same intercept, right?
I'm not really trying to predict where they intercept, though they would actually intercept at 0, right? So in other words, at this point, where in the long run point where inflation,
Okay, yeah.
target inflation rate, and output is equal to 0, they would be the same. But the main point I'm trying to illustrate is the slope, right? That the slope of an aggregate supply curve with a higher V has to be steeper than the slope of an aggregate supply curve with lower V, right? So that's the main story I'm trying to tell, is just the slope. That makes sense, Ben?
Yeah.
Okay, good. Okay, so now putting it all together, let's think about our aggregate demand, aggregate supply model. That's aggregate demand. Here's aggregate supply. Okay. And what's true in the long run? In the long run, it's got to be true that inflation this period has to equal inflation last period, and they all have to equal that targeted inflation rate. And it also, as always, has to be true that short run output is equal to 0. Okay. Now, this aggregate demand, aggregate supply model is a lot trickier than you might appreciate. What's going on in this model is quite a bit more, well, let me say complicated. And the reason is, notice that this is a dynamic model. We have time t and time t minus 1 in this. And by making this a dynamic model, this makes it more realistic, but it also makes it a little bit more complicated. And so we have to be very, very careful about thinking through the transition past the dynamics of models that are dynamic, right? Because what we see is that their movements over time become much more complicated. We don't just jump from this point to that point, but we actually have to think about how we transition between one point and another point. Okay, so let's talk about an example here of using this model. And this is going to be quite a complicated example. It's going to take us a while to work through. So hold on tight. All right, example number 1. Let's talk about a positive aggregate demand shock here. Right, a positive aggregate demand shock in which A bar is greater than 0, right? So aggregate demand goes up. So I'm going to try to draw this as big as possible. We're just going to have to see how this graph looks on this iPad. Here's a spot where it'd be a lot easier if we had a board. okay? So here we are at the beginning, and we always, in these kind of questions, we always assume we start in the long run, right? Just to kind of keep our analysis simple. And then now, what happens in period 1? A bar goes up. And inflation goes up. Okay, that's pretty simple, right? A bar increases their IS curve, and for the same reason, it also increases our aggregate demand curve. So if I can scroll down here, what do we see? That short run output goes up and inflation goes above the targeted inflation rate. But here's the problem. Is that the end of the story? That can't be the end of the story, because notice what I should also have written here. Inflation is greater than inflation in time t is greater than inflation in period t minus 1. What does that mean? If we go back here and look at our aggregate supply curve, it means our aggregate supply curve is going to have to move, right? If inflation this period is different from inflation last period, this is actually going to have to move. So what's going to happen in period 2? In period 2, switch to another color here. Because inflation went up, we know this is going to happen. It's going to shift the aggregate supply curve to the left. As PT minus 1 adjusts. So in other words, in period 2, what's going to be PT minus 1? It's going to be what inflation was last period. So inflation last period gets incorporated into the aggregate supply curve in period 2, and what happens? This shifts in this direction. And where do we end up? At this point. So basically, our aggregate supply curve is catching up. I can write this down at the bottom. Short run output falls a little bit. But it's still greater than 0, right? So short run output falls a little bit, but inflation actually gets worse. Why? Because what's happening is that everybody's catching on to that rise in inflation, and they're beginning to incorporate it into their price setting. And so when when we had this positive aggregate demand shock to begin with, now aggregate supply is catching up to it. And that's also driving inflation. What's going to happen in period 3? In period 3, I'll draw it again, but we really have the same thing happening. that short run output falls again a little bit. And actual inflation rises a little bit. Here, I'm sorry, I keep on wanting to scroll up and down. It's probably hard to do this. So in period 3, short run output falls a little bit more and inflation rises a little bit more. Notice that we're going, so period 3, etc. Short run output is going back towards 0. But inflation continues to increase. Inflation continues to increase, short run output begins to rise. What happens if we get all the way back up here, the short run output is equal to 0? Can that be a long run equilibrium for us? No, Bram, I saw you shake your head. Yeah, you're correct. It can't be a long run equilibrium. And why? Notice here that what's happening, we're getting to a point where inflation is way above target. And why is that? Because A bar is still greater than 0. We just assumed that aggregate demand went up, but it never came back down, right? It never came back down. And so this long-lasting aggregate demand shock, it continues to push up aggregate demand. So let's think about what will happen eventually. Eventually, A bar is going to go to 0 and aggregate demand is going to return to its original point. It's going to go down. So in terms of our graph, what's going to happen eventually? Eventually, aggregate demand is going to fall way down here, and we're going to move all the way down to this point. But notice what's happened now. When this does happen, now we overshoot short run output. Now we overshoot short run output. When aggregate demand falls a lot, short run output is also going to fall. In fact, it's going to fall below 0. Why? Because aggregate supply curve has shifted so much. So now we have this big drop in short run output as our aggregate demand curve comes back. And then we also have a big drop in inflation. Now what's going to happen? Well, I'm running out of colors. We'll move the yellow. Now what's going to happen over time is now the aggregate demand curve is going to start shifting to the right. Right? And short run output is going to begin to come back to 0. And inflation is going to go back to target. But that process is going to take, once again, many periods because it's a dynamic model. We transition. So over time, aggregate supply now shifts to the right. That moves short run output back to zero, and it moves inflation back to its long run target. How long does this take? A long time. What we get here is we get a lot of volatility from just one shock. So all it took was one shock to get a lot of volatility in short run output and inflation that lasts a long period of time. This is dynamics. This is dynamics. Okay. Let me just review this. This time I want to show you the graphs because as I go through this, I worry that my graphs are a little bit too messy. Let's look at the graphs that the book uses. And let's see if maybe the book works through the same example. Let's see if we can figure out what's happened. So first period, right, this is just a review of the same example. A bar is positive, and notice that an increase in A bar shifts the aggregate demand curve up, and it moves us from point A to B. But now what's happening? Inflation expectations have to catch up because notice that actual inflation went up, but what happened to expected inflation? It didn't change because expected inflation is just what inflation was last period. So now, because inflation this period is greater than inflation last period, the aggregate supply curve is going to shift up slowly over time. And we're going to move from point B towards point C. Your book here has this drawn as just one big shift, but notice here it actually says aggregate supply 8. I don't know where they're getting the 8, but it's going to take a long number of periods, right? So this is not the move from B to C doesn't happen just in one period. It's going to happen in multiple periods. In which case, short run output is going back towards zero, but inflation is going up. But that's not the end of the story, because what happens eventually? Eventually, A bar comes back to zero. And when it does, we move from C to D. Meaning now short run output is negative. And so now what has to happen? Aggregate supply curve has to shift to the right to move us towards A, and move short run output back towards zero, and move inflation back toward trend inflation. Okay, so we move from A to B, B slowly to C, C to D, and D slowly to A. That's what's happening in this model because of the dynamics in it. And they're really simple dynamics, but they, it creates a much more complex and, quite honestly, rich story about how an aggregate demand shock can have long-lasting impacts on the economy. Okay. Is my, hold on, what's going on here? There we go. Okay. So what we get here, oops. You get, for lack of a better word, counterclockwise movements in inflation and output, short run output. Counterclockwise movements in inflation and output. So to flip back to this graph, right, notice what's happening here. We move, let's see, keep this in black. We move here, and then we move here, and then we move here, and then we move here, right? Oops. So we're having counterclockwise movements. We have an increase from here to here. We have an increase in short run output and an increase in inflation. And then we have a decrease in short run output and an increase in inflation. And then we have from here to here, we have a decrease in short run output and a decrease in inflation. And then from this point to this point, this is a crazy graph. We have an increase in short run output and a decrease in inflation, right? So we're seeing all sorts of different combinations, all sorts of different relationships between output and inflation based on where we are in this complicated cycle, right? So this is some really, really, you might say it messy, but I'll say realistic dynamics about how output and inflation are related, right? So one of the things we want to talk about here in a couple of minutes is, can we use stabilization policy to preempt? I don't know why I put spelled like that. Preempt is with. Is that right? Why can't I think of how preempt looks this morning? There's two E's. Two E's, right? Yeah, I think that's right. It's embarrassing. Neither way looks right to me this morning. Hold on, this is why God gave us Google. Yes, two E's. Why does that look strange to me?
I think you muted yourself.
Yeah.
Sorry, can you hear me now? I don't know how that happened. So yes, the question here this afternoon is, or for most of the rest of the day is, can we use stabilization policy to preempt this complicated process, right? If the economy is left to work itself out, can it do it? Sure, but what's the problem? It's going to take a long period of time. And in between, there's going to be a lot of complicated volatility. And that volatility is probably not great for most of the people involved, okay? So that's going to be, much of the rest of the theme of the day is how exactly would this look? Before we do that, though, I want to work through a couple of more examples using this aggregate demand, aggregate supply model, but I think we better take a break. So let's take a 5-minute break, if that's okay. I'm sure it is. And then we're going to come back, talk about a couple more examples, and then get into this question of, what really should stabilization policy look like? So, all right, see you in 5 minutes. Hey, everyone. So Ben, I spent about an hour on the phone with an airline this weekend on hold, and it sounded exactly like that. For a second, I thought I'd been.
Oh, sorry, I had my mic unmuted. My bad.
No, that's all right. I actually liked it. It sounded good, but it sounded very much like the music they play when they put you on hold for an hour. So I guess that's kind of insulting to you. I don't mean to be insulting. I'm just saying. All right. So let's jump back into this and let's talk about another example of using this aggregate demand model. This one a little bit simpler, I think. So the first example we talked about was a demand shock. Let's talk about an aggregate supply shock. For instance, what happens if O went up? And let's say that O is greater than 0 for just one period. Okay, so it's just going to be greater than 0 for one period. What would this look like in our model? So here we are, aggregate demand, aggregate supply. We start in our long run equilibrium, as always. Now, what happens in period 1? Well, because O bar is greater than 0, aggregate supply shifts to the left. And don't get confused about this, right? This is a kind of an easy thing to mess up. An increase in O0 moves us towards higher inflation, meaning inflation shifts up to the left. And what happens to short run output? Short run output falls below 0. Hopefully that's pretty straightforward. Now here, maybe the more interesting question is, what happens in period 2? Now, that shock goes back to 0, right? That shock goes back to 0, but the aggregate supply curve does not does not shift all the way back. Because once again, we started a dynamic process, right? Now inflation is greater than what it was last period. And so that prevents the aggregate supply curve from shifting all the way back. What's going to happen here? In period 2, it's only going to shift part of the way back. And inflation is only going to come part of the way back down. Okay. So short run output comes part of the way back. Inflation comes part of the way back, but not all of the way. So short run output remains below 0 and inflation remains above the target. What happens in future periods? Well, short run output goes back to 0 and inflation goes back to the target slowly. As aggregate supply shifts to the right. So will we get back to the long run point? Yes, but it's going to be a slow process. So in our graph here, right, how this aggregate supply curve is going to have to, is really hard to draw, but this aggregate supply curve is going to slowly shift to the right, moving inflation down and short run output towards 0, right? So in future periods, yeah, we go back to the long run, but only slowly. Notice here what's happened. A 1 period shock a 1 period shock essentially lasts multiple periods. So it only had to happen one time, but it takes multiple periods for us to get back to where we were. So in this dynamic model, what do we get? We get long-lasting effects from exogenous shocks. So any sort of exogenous shock leads to long-lasting effects. And so this, in this example, the economy is very vulnerable to supply shocks, right? Very vulnerable to supply shocks. And we can think about this, as having a lot of implications. Just kind of think about the news. This, to many economists, this points to the fact why we shouldn't be too optimistic about the vaccine and an end to COVID, or at least an end to the economic effects of COVID anytime soon, right? I've gotten a sense in the newspapers and even talking to friends that a lot of people are like, oh, we got the vaccine, it's shifting today. Yeah, in about 3 months, this whole thing should all be over. I doubt it, right? Because even once the shock itself has disappeared, it's going to have long-lasting effects. We've been knocked pretty far away from trend, and it's going to take a while for the economy to transition back to trend. And so we should not expect the economy to just, boom right back to where we were a year ago. This is going to take some time, right? This is going to take some time. Let's do one more example here. Let's think about what would happen if the central bank move towards tighter monetary policy. In other words, they had an inflation target to begin with, and then they lowered their inflation target. What's this going to look like? So once again, started our long run spot. Now, the central bank imposes a lower inflation target. Okay, so what should the central bank do? Well, what they have to do is they have to raise interest rates and shift down aggregate demand, right? And you notice, actually, maybe I should write this another way. Make this clear. Pi bar, in other words, the targeted interest rate, is an argument in aggregate demand. So the reduction in the target inflation rate directly reduces aggregate demand. How far does aggregate demand fall? Well, here's the tricky thing. It's not going to fall all the way to reduce inflation immediately to the new target. It's only going to fall part of the way, right? In other words, it's only going to fall far enough so that when short run output is 0, we're at the new inflation target, okay? So it's not going to fall all the way there in the first period. But it is going to fall far enough that we have a recession. So inflation is going to go down, but not all the way to the new target. Then what happens in future periods? Now inflation has fallen. So our aggregate supply curve is going to shift to the right. And this is going to move short run output back to 0 and slowly move inflation to eventually its new target. Okay. So in other words, back to our graph, what's going to happen in future periods is aggregate supply is going to slowly shift this way. Short run output slowly moves back to 0, and inflation slowly moves down to its new target. Once again, dynamics. Once again, dynamics. So yeah, this is a lot more complicated story, isn't it? It's a lot more complicated story than we kind of taught in our, if you think back to principles where we had an aggregate demand, aggregate supply model, that those were static models, right? Remember, static, you have to think about like as photographs. You take a snapshot at the beginning, you take a snapshot at the end, voila, that's what happened. But there's no element of time in that analysis, right? That aggregate demand, aggregate supply model that we talked about in principles, time was not an element in that. Here now, time is an element. And so we actually get a transition by which we move to the long run. And what we see is that transition can be messy. Those transitions can last a long time. And what that does is that really increases the consequences, either the costs or the benefits, but likely the costs of exogenous shocks. And so when we move to a dynamic model, in many ways, it puts more emphasis on stabilization policy because these shocks can have very, very long lasting effects on the economy. Now, you might ask, well, that's all fine and good, but is there actually any evidence to support this short run model? Right, we've developed a model here. We've made a lot of assumptions, but is there really any reason to think that this is at all the way the world really works? And so I think there is. And so let's just talk about this for a minute. The first question we could ask ourselves is, does the Fed follow a policy rule? Like the one we assumed? Does the Fed actually follow such a policy rule? Okay. Well, let's rewrite this policy rule like this. I'm going to put R bar on the other side. Okay. And then remember that the nominal interest rate is equal to the real interest rate plus inflation. Okay, in the long run. So the nominal interest rate is equal to the real interest rate, which is that, plus inflation. And so we can rewrite this monetary policy rule in terms of nominal interest rates. Okay, so all we've done is just we've taken this nominal, this interest rate rule that we wrote in terms of real interest rates, and we wrote it in terms of nominal interest rates. Now, let's make some assumptions here. Let's assume that the marginal product of capital or the real interest rate is 2%. Let's assume M bar is 0.5. Let's assume that the target rate is 2%. Okay. And then let's see what this looks like. Right, let's see what this looks like. So let me switch over to my notes. Hold on 1 second. Okay, here we have figure 13.16 from your book. The blue line is the federal funds interest rate. Remember, this is what the Fed typically focuses on. So this is the actual federal funds interest rate, right, which represents actual Fed policy. And then the green dotted line is our policy rule. And so the question here is, does our policy rule look like what the Fed actually does? And I think what we can say is, yeah, it's pretty accurate. It's pretty accurate, but there are some mistakes, or there's some big differences. First, look at in the 1970s, notice that the policy rule said that inflation, that the interest rate should have been much higher than it actually was. In other words, the Fed was too loose. The Fed kept interest rates too low, much lower than what the policy rule would predict. And then look at the end here, out at the end. What's going on out here? Well, here, this raises some real questions about our policy rule, right? Because the policy rule says that interest rates should be much higher than what the Fed has kept them. So I think what we can say here is that, yeah, in the long run, this policy rule kind of mimics what the Fed does, but then maybe not, right? I mean, there are definitely some big differences between this simple rule and what the Fed does. And we might be able to guess what those differences are, right? And the difference, quite honestly, is that our policy rule doesn't think about output. Our policy rule assumes the Fed only worries about inflation. But in reality, we know the Fed also worries about output. And so that's something we're going to come back and talk about this afternoon. How would we adjust the policy rule to incorporate output? And does that do a little bit better? And what we're going to see is yes. If we include in our policy rule a worry, the fact that the Fed worries about short-run output, we'll find that our policy rule mimics Fed behavior much better. Okay, so I guess the answer to the first question here would be, does the Fed act or really behave according to a rule? Well, not this rule, right? I mean, yes, roughly, but I think in terms of details, I think we can develop a better rule that probably more accurately measures what the Fed does. Here's the second question. Do we actually get counterclockwise movements in inflation and output? Do we actually get counterclockwise movements in inflation and output? Okay. In other words, if I go all the way back to my crazy graph, right? Do we get this movements to the right and then the left, the right and the left, the right up, the left down, the right down, right? Do we get these kind of movements where output and inflation go up, then output goes down while inflation goes up, then output goes down while inflation goes down, and then output goes up while inflation goes up? Well, okay, so this is a complicated graph, and so you're not going to be surprised that the answer to this is complicated. Probably more complicated than what we want to get into in this class, but let me try to give you at least a simple argument here. So here is figure 13.17. This is plotting inflation and short-run output in the 1960s through the 1980s, early 1980s, okay? And it's connected a line so that 1961 connects to 1962, that connects to 1963. And so what you really need to do here is you really need to trace this line over time. And this is hard for me to do on a computer. It'd be a little bit easier if we were in class. And I could kind of show this up on a screen and then kind of trace it with my pen. But if you look here, beginning at this point, right, at 1960 and 1961, notice how from 1961 to 1962 to 1966, we move up to the right, and then we move up to the left to get to 1970. And then we move down to the right to get to 1972, and then up to the right to get 1973. And then we move to the left, up in the left, and get to 1981. Whoops, I'm sorry. We get to 1974. And then we move down to the left to get to 1975. And then we move down to the right to get to 76 and up to the right to get to 78. Up to the left to get to 79, up to the left to get to 80, down to the right to get to 81, right? Then we kind of have a little bit of a break in this pattern. But yeah, you can kind of see it, right? Maybe you can kind of see these cyclical patterns, right? These kind of counterclockwise movements between inflation and output. What happens if you look here between 1983 and 2000 and what is it, 2011, I think. What's the last date? No, I'm sorry, 2018. I'm not going to try to trace this one out. This one is very complicated, but you do see some remnants of these cycles once again. And so empirically, if we did some regression analysis, what you find is that, yes, these cycles, I would say, are complicated and they're not strongly predictive, but there is some empirical evidence that these things do exist. Now, it gets complicated by other things because the cycle kind of breaks. The cycle is based on aggregate demand shocks. If there's other kind of shocks, like an aggregate supply shock, you're going to get a different pattern between inflation and output. So I don't know how much weight we should put in this, but I will say that, you know, there is some evidence that we do get these weird, or I shouldn't say weird, these complicated relationships between inflation and output, okay? They're there. And so, you know, when you see that kind of complication, what it really suggests to you is that there's a lot of complicated dynamics going on here. And I think our model, at least partially, helps us understand that. All right, third question I want to look at here, very briefly, is if you remember all the way back, the first day of class, we talked about the macroeconomic process. The macroeconomic process is 1, collect data, 2, develop a model, 3, see if the model matches the data. And I think we have some evidence that this model matches the data. But the fourth step of the macroeconomic process is ask ourselves, can we use this model to predict? Can we use this model to predict? And I'll say on this, the record is no. That while this model might have some usefulness for us, one of the things that we're going to see is that macroeconomic prediction is just weak. It's just weak. And, you know, I think we can be very clear about why our models don't do a better job at predicting. Our models in general can't identify turning points. Because exogenous shocks are going to be very difficult to predict, right? And so that turning point, when things are going good and then something happens and they start going bad, that's where our models have a hard time because we are not very good at predicting these exogenous shocks, right? I saw an article, I should have shared this with you, but it was an article that was basically blasting the economics profession for being so optimistic about output in 2020. And I kind of wanted to be like, Jesus, I mean, I don't want to defend economists all the time, but can't you give us a break on this one? Right? I mean, you know, COVID was a classic example of an exogenous shock, something that was going to be very difficult to predict. Now, you know, people have been talking about, yes, we're going to have a pandemic, but it's one thing to say we're going to have a pandemic at some point. It's something completely opposite of that, or something completely different to say the pandemic is going to happen in March of 2020, right? So yeah, you know, things happen that we can't predict. And as a result, that's when our models do the worst job. So in other words, in many ways, when we need prediction the most, our models are going to do the worst job. And so what tends to happen is we become too optimistic during bad times, too pessimistic during good times. When the economy is growing very strong, in other words, when we have positive exogenous shocks, we're going to tend to underpredict. And when the economy is weak, we tend to overpredict. Why? Because we think our models and data are reliant on future looking like the past. So our models and the way that we incorporate data, they work well when the when the future looks like the past, right? When the future looks like the past, our models tend to do well. When the future doesn't look like the past, our models tend to make big mistakes, right? So yeah, you know, I mean, that's just where we are, right? That's just where we are. If I can show you, just to kind of illustrate this, let me show you some predictive results from the 2001 recession. So the 2001 recession was not a very big recession, or I'm sorry, 2008 recession, that's a typo, sorry about that. The 2008 recession. So the 2008 recession was a big recession. And so this is a little difficult to read this, but basically each of these lines are the predicted output for the future at different points in time. So remember, the 2008 recession actually began in the fourth quarter, or it began in the fourth quarter of 2008, okay? So the 2008 recession began in the fourth quarter of 2008. Back up, sorry, I'm getting my dates confused. Began in the fourth quarter of 2007, right? Began in the fourth quarter of 2007 and ended in the third quarter of 2009. Okay, so I'll say that again. It began in the fourth quarter of 2007 and ended in the third quarter of 2009. So here we are. This is the first forecast in the fourth quarter of 2007. And what's it predicting about output? Output's just going up. Nothing's going to happen. Don't worry. Okay? In other words, we did not predict this recession. Our models did not predict this recession at all. What happens is we get to the first quarter of 2008. We're in the recession, and yet our models are not predicting it. Why? Because we only get our data with a lag. So we're in a recession, and yet we don't even get the data yet to tell us we're in a recession. So our models are still predicting that things are okay. It's predicted that the economy is going to slow a little bit, but it's still predicting it's up. Then what happens in the second quarter of 2008? Well, now we're starting to catch on, right? Our models are starting to catch on, but it still predicts a very, very shallow recession. Then we go to the third quarter of 2008, still a shallow recession. Only when we get to the fourth quarter of 2008 is it really starting to predict a real recession. And then when we get to the first quarter of 2009 and the second quarter of 2009, it's predicting a catastrophe. Of course, right when our models predict a catastrophe, what's happening? Now the economy is starting to bounce back a little bit. So in the third quarter of 2009, the recession's over, but what's our model predicting? Our model's predicting several more quarters of recession, right? So in other words, our models are just always running behind what's happening, right? It predicted things way too optimistic at the beginning of the crisis and way too pessimistic towards the end of the crisis, right? And that's just the way that things tend to work, right? Our economics in many ways is not a predictive science, in part because those exogenous shocks are very unpredictable, and in part because our models are always reliant on the past being reflective of the future. And when the past does not reflect the future, we tend to make big mistakes. So when I say that economics in large part is not a predictive science, I don't think that doesn't damn the study of economics, right? I mean, I still think economics has a lot to tell us, but we need to be very cautious about, how much that we can predict the future, right? I think, one of my favorite definitions of an economist is that an economist is somebody who can tell you why something happened after it happened. That economists, in many ways, we should look to historians more than we should look to futurists, right? Because economists are likely never going to be great futurists. In some sense, what we do, where our strengths are, is always looking to the past, right? But the future is hard to predict, in part because economics is evolutionary, right? I mean, I wish that economics was as simple as geology, right? Geology in many ways is simpler, not to knock geology, but in many ways the past gives us a lot better predictions of the future in a discipline like geology, because evolution in geologic terms takes place so much more slowly. But evolution in economic terms takes place very quickly. And as a result, we tend to miss stuff, right? We tend to always be behind. We tend to always be looking at the last recession, not seeing the next one, right? And so, we always have to be very humble about our ability to predict, I would say. Okay, well, this seems like a good place to break off. So where I want to come back this afternoon, we'll meet back here at 12:30, is I want to talk a little bit about thinking about stabilization policy and how we might model stabilization policy better in our model. And then after that, I want to review homework number 3, okay? So to give you like a little bit of preparation for homework number 4, which is going to be due on Wednesday, okay? So that's what we will do this afternoon, all right? Okay, well, have a good lunch, and we'll see you back here in about an hour and 45 minutes. All right, have a good break.